Hi, my name is Kacper Szurek, and in this episode I will try to explain two last vulnerabilities inside Signal Communicator. I hope you will like it. Those vulnerabilities are very similar to each other, but bugs related to them are inside the different part of the code. Let's start from exploit 2018-10994. How was it discovered? Two security researchers writing to each other using Signal. Suddenly, one of them sends a link to the vulnerable website. This URL contains malicious cross-site scripting payload which will be executed as JavaScript code on an exploitable website. They were very confused when desktop app renders this URL as an image. Normally, Signal prints it as a plain text message. After a few tries, they discovered that using this technique, they can display any HTML tag. There is one prerequisite here. Payload must be part of the link. This guides us to the first bug. Signal, similar to the most modern applications, automatically converts text, which contains URL address, to clickable ref. Because of that, when someone sends you some interesting website, you don't need to manually copy its address and paste into a browser window, but just click on it. Internally, Signal passes text into Signal HTML render function. All special characters from a message, like greater than or lower than, are converted to entities. What's an entity? In HTML language, some characters are reserved. For example, when you want to bold your text, you need to use B tag. Browser detects this sequence as HTML tag and bolds your text. What if a user wants to put the text B on the website and don't want to treat this as HTML tag? That's job for entities. You only need to convert greater and lower than character to an entity and it's done. Right now we know what entities really do. Let's back to render function. As I mentioned before, Signal passed text to this function. All special characters were converted to entities, so they cannot be rendered as HTML tags. Inside those functions, Signal calls module linkText. This module uses an external library, Linkified. This library is used to detect links inside messages. We can check how this library works using its testing website where the author shows all supported URL formats. After checking source code, we can discover that implementation of the function setLinkifiedContent is very similar to the createLink function from Signal. Indeed, Signal authors confirm this inside comment. One of difference between those two is a usage of the decode URI component during URL rendering. What this function really do and why it's important here? This function converts escape sequence into text. Each ASCII character can be presented using %sign and number in hex. For example, %20 gives us space. Let's check why this function makes all code vulnerable. First, we need to save a local copy of the Linkify website. Now, we are pasting malicious HTML payload. As we can see, library detects our URL because indeed it's a valid one. It starts from HTTP, then domain name, and encoded test parameter. Now, we slightly modify function adding decode URI component so it looks similar to Signal implementation. Now, test is bolded, so HTML tag was rendered. It works that way because this function converts each number, which starts from % into its ASCII representation. It works that way also for greater and lower than character. Because of that, we can create new HTML tag. Signal developers fix this bug by removing Signal HTML render function reference and converts it to a big regular expression, which supports only HTTP, HTTPS, and FTP addresses. It's quite interesting because this expression exists inside Signal for a quite long time, but recently was replaced by the new solution. In theory, this new solution should support more URL formats. We know how bug looks like in theory. It's a demo time. As you can see, I have an old Signal version installed. Now we are waiting for malicious URL from our colleague. It can contain every HTML tag, but it needs to be properly encoded and be part of the link. Why does it need to be part of the link? Only links are passed to exploitable createLink function because it takes data from Linkify library. For example purpose, I will show a frame with test text. A frame is nothing really fancy, but demonstrates that attack works. Really dangerous will be executing JavaScript in Signal context. Let's try to send a message which should display JavaScript pop-up with test text. Our code is hosted on HTTP server created using Python one-liner. As you can see, the code doesn't execute. When we go into Developers Tools, there is a CSP error there. CSP is a construction which can define which external resources will be loaded by the application. In the real world, this protects the user against cross-site scripting attacks, because the app can load only trusted JavaScript code. It will be easier to demonstrate this in the example. Here, we have simple HTML page which displays window with test text using JavaScript. As you can see, it's displayed correctly. Now, we are adding CSP policy. This time, window doesn't show, and inside console, we got information that this code violates our policy. Proper usage of these headers is not so easy. When we check Signal, it's clearly visible that frame policy is missing. Because of that, iframes can't be rendered correctly. What is more interesting, it looks like on Windows, when you load code into the frame using Samba protocol, CSP doesn't work correctly and doesn't protect the user. What's Samba? It's a networking protocol mostly used when you want to share some files under Windows. In the normal browser, we cannot reconstruct this situation because browsers don't allow to load code that way. The Signal is written using Electron. It's some kind of framework which allows creating multi-platform apps in JavaScript. It allows loading code using the network share. Information about this functionality is available on Electron Backtracker. When you want to load external JavaScript from the network share, it needs to be anonymous. It means that every user can open it without proper credentials. To do that, we need to add guest user and give him proper share permission. Also, it needs proper file permission. Now, everyone can read any file from this share without login. Next, we are creating simple Electron app. This can be done using few simple commands. After that, we are adding CSP policy into this example and tries to load our JavaScript payload through a network share. As you can see, this attack is successful. After adding frame directive, we cannot load file anymore. So why displaying external window is really dangerous to the end user? The Signal is a very security-oriented app, which makes the big focus on a message encryption. But it's possible to obtain all user messages and send them to attacker server using a technique which I described previously. Why? The Signal app is some kind of website with a lot of JavaScript and HTML code. If you can execute any JavaScript inside Signal context, it means that you can read any Signal data from the app and send it anywhere. To prove you that, I will use exploit presented by bug finders. First, we need to change server address so we don't send data outside our environment. Then we need to create simple HTTP server which reads all post requests, decode them using the base64 algorithm, and save into the file. Now it's time to demonstrate this attack. After we receive the malicious payload, our temporary server gets stolen messages. Now, I will explain the second exploit. How was it discovered? When one of the security researchers saw a tweet about first Signal bug, it wants to recreate it. After a while, he executed HTML. It was really simple, just send HTML tag and then quote message. Originally, he thought that he discovers the same bug as other researchers. But after a while, he realized that it's completely new Signal flaw. This time, developers used dangerously set inner HTML function. In the documentation, there is a warning that creating HTML from user data using this function is not a great idea and can lead to cross-site scripting attacks. Why? We have a simple element on our website with test ID and we want to change its content using JavaScript. We can use inner text function. As you can see, the text is displayed correctly. Let's assume that this text should be treated as a HTML code. Now we need to use inner HTML function. And what can happen if this text comes from the user? The user can use it to execute any code. And exactly this happens to Signal because a quoted message is directly passed to dangerously set inner HTML. And as you can see, the quoted message is controlled by the attacker. It's time for a quick example. And that's all I want to show you during this video. Simple mistakes can be made also by big companies inside big applications used by the millions of the users. To sum up, never use functions which converts user data into HTML content. If you like this video, you can subscribe my channel. More information about my new projects are available on my Twitter, Kacper Szurek, and on my website securityszurek.pl.